Hi, my name is Quan. Today I'm going to present for the homework YouTube 7. So this is my total file, and this is the first helper function. Actually, it's the first. And then this is the isPram function, which I downloaded from you. Actually, I can drop it from my folder too, but that's okay. It will try to define that is that number you put in here, the n number here, is a prime number or not. If it's okay, it's return false, and if it's not okay, it's return false, and if it's okay, it's return true. So the definition, the next function is the direct sum of the number. So I put any number into here, which is n, and we just sum all of the digits of that number. I really like this part. Personally, I really love these two lines. I think that will be helpful in my later study. So the question is to write a function that returns a list of all prime numbers less than 1000 with a giant sum of 10. So for the first part, return a list of all prime number which is less than 1000. I use the for loop. First, then I still create an empty list, and then I use the for loop. So for n in range 2 to 1001, I put the condition if it was a prime number. Then, like your question, with a digit sum of 10, so I put it here. If the digest sum of this prime number is equal to 10, I will put that number into my list, and so I will got the list. I will run the code later after I explain this one. So primes with digest sum lower upper ds. So the second questions you asked me to generalize my code with the function. So this is my answer. So I just modify some of this one. So this is the same one. The lowest is lower. In the upper I plus 1. So I just for loop this one. This one is equal to, and ds I put it in here instead of 10. I put it ds and also pin, just like the same. So now I will promote the code. Copy it. Yes, this is this one. Of the prime numbers which has the digit sum of 10. So the next one is this one. Oh, I shouldn't do that. So the next function is prime with any. So I want to try something 2011. So here's the list. So that is the end of the first and the second question. So now I move to the extra credit part. So the extra credit part requires me to bring out a nicely formatted table with columns of digit sum and brands with digit sum for brands less or equal than 1000. So I try to do that here. Now see, this is my format table, and I create an empty dictionary to do that. So copy all of these helper functions, like you say, like the same as the first and the second questions. I put it in here, and now I create my main function for the describe credit part. So my idea is still the same for n in range from 2 to 1001. I check it if it was a prime or not, and if it was a prime, I put that prime number into here so I can take the digit sum of the prime number. And I will put that back to a list, which is the digit sum is the key and n is the value of the dictionary. And here is how I format it. Let's check it. Oh man. Oh, sorry. So this is my table. It will run from here to here. So this is the digestion, and this is the prime with that digestions equal to each other. But I realized that if I just let this table here, I cannot answer the question, so I just do a little modified it to try to short the digestion. So I came up with this idea that I create a list for the sum of digest. Here is the same as that file, where I just put all of the digestion into a list and I short it. So now I run it. Oh, and I got a list of the sum of the digest from of all the prime number from 0 to 1000. So now I can answer the question. Is there a most common digest sum for the primes? Yes, I think that 17 is the most common digest sum because it's bigger. It repeats many more time than any of the digest sum. Yeah, the 2 had just repeat 3 times, but 17 is repeat about 19 times. Yeah, it repeats 19 times, and there is no more digest. There's no digest has more repeat times than this 17. So the answer for my first question of this extraordinary part is 17. And the second is every digest sum from the minimum to maximum digest sum possible? Or are the gaps? Well, I don't understand much of these questions. Um, so we answer this. Um, I have shorted it from the minimum to the maximum of the digestion, and I found that there are pretty much of gaps between that. From 5 to 7, there's no 6, so there's a gap here. So from 8 to 10, there's a gap here because there is no 9. From 11 to 13, there's no 12. 14 to 16, there's no 15. From 16 to 17, there's no. Actually, there's no gap here. So from 17 to 19, there's no 18. It's from 20 to 22, there's no 21. Actually, there's from 22 to 25, there's no 24. So there are gaps between the digestion, and I have shown all of that to you. So if there are gaps in the digestion, what is the largest gap? Actually, all of the gaps are equal. If you say that about the difference between the gaps, if you ask me to choose the big gaps, I don't know, it's just like I'm confused about this one. But anyway, I said that if there is a gaps, if there are gaps, they are same equal. Thank you for listening.